In April 1815, a mountain in Indonesia exploded. It was the most powerful eruption in recorded human history. 800 megatons, roughly 50,000 Hiroshima bombs in a single afternoon. Almost nobody knows its name. And the year that came after, the year that ended snow in June, emptied half of New England, invented the bicycle, and birthed modern horror, almost nobody can explain. This is what happens when the sky stops being normal. 1815 was supposed to be the year the world settled down. In June, the British and Prussians defeated Napoleon at Waterloo. In November, the Congress of Vienna finalized the new map of Europe. A generation of war was over. Trade routes were reopening. On the other side of the world, on a small Indonesian island called in the Dutch East Indies, a mountain called had been quiet for as long as anyone alive could remember. Before the eruption, Tambora was 4,300 meters tall, one of the highest peaks in the archipelago. Two small kingdoms, Tambora and Kiu, lived on its slopes, growing rice and trading with Javanese merchants. In the spring of 1815, the mountain woke up, and 10 days later, neither kingdom existed. The first explosions came on April 5th, 1815. Booms were heard 1,200 kilometers away. British and Dutch naval officers across the region thought they were under attack and dispatched warships to investigate. But the real eruption began on the evening of April 10th. 3 columns of fire rose from the summit, joined into a single mass, and lifted ash and sulfur to an altitude of 43 kilometers, well into the stratosphere. The roaring was heard 2,600 kilometers away. That is the distance from Berlin to Moscow, from Tokyo to Singapore. The mountain lost 1,500 meters of height in 24 hours. Where the summit had been, there was now a hole 6 kilometers wide and a kilometer deep. The British Lieutenant Governor of Java at the time was named, the man who would, 4 years later, found Singapore. He collected eyewitness reports from across the East Indies. In one of them, from on Java, 1,300 kilometers away, the ashfall was so thick that, according to Raffles, persons walking out in the open air were obliged to use lights. At noon. On Sumbawa itself, 10,000 people were already dead. The bigger numbers were still coming. Here's what almost nobody outside specialist climatology knows. When a volcano explodes hard enough to punch through to the stratosphere, the layer of the atmosphere above ordinary weather, it does something almost nothing else on Earth can do. Sulfur compounds injected into the stratosphere combine with water vapor to form droplets of sulfuric acid. These droplets are tiny, small enough to stay airborne for years, and they reflect incoming sunlight back into space before it ever reaches the ground. Tambora ejected about 30 megatons of sulfur into the stratosphere. The resulting aerosol veil spread across both hemispheres within 6 months and dropped global average temperatures by close to 1 degree Celsius for nearly 3 years. A 1 degree global average sounds small, but that is the average. Regionally, in certain parts of the northern hemisphere, summer temperatures dropped by 2.5 degrees, and weather patterns, not just temperatures, became scrambled. In New England, the summer of 1816 began with a frost in early May, and then it did something New England had never done before. On June 6th, 1816, 6 inches of snow fell across Vermont, New Hampshire, and upstate New York. Birds froze in midair. Sheep newly shorn for summer died of cold. In Salem, Massachusetts, the temperature dropped 30 degrees in 30 hours. A Shaker community member at New Lebanon, New York, named Arpihor, wrote in his diary on the day of the snow, "All was froze. The hills were barren like winter. In Plymouth, Connecticut, a clockmaker named walked to work that July wearing a heavy woolen overcoat and mittens. Every single month of 1816 had a hard frost somewhere in New England. 3/4 of the corn crop was lost. By autumn, farmers were selling cattle for almost nothing because they could not feed them through the winter. The popular name for the year, already by August, was 1800 and froze to death." This episode is brought to you by a research community that studies exactly this kind of cascade. Every time a climate signal arrives, in a volcanic winter, a drought decade, a monsoon failure, most contemporaries miss the cascade that comes after. The documents are there in the archives, written in real time. People just don't read them carefully enough. The link below is to the unedited collection, the original diaries, customs records, harvest tallies, from every climate shock since 1780, now back to 1816. The first cascade was migration. Between 1815 and 1820, an estimated 800,000 New Englanders moved west. The largest single spike was in the 4 years immediately after 1816. The press of the time called it Ohio fever. In those 5 years, the United States admitted 5 new states, the fastest pace of statehood admission before the Civil War. Vermont's population growth went negative for the first time in its history. Towns in New Hampshire lost a third to half of their population in 3 years. In Norwich, Vermont, a farmer named Joseph Smith packed his wife and 8 children into a wagon in 1816 and moved them to Palmyra, New York, because his Vermont land would not grow food anymore. His 11-year-old son, Joseph Smith Jr., would later report visions in the woods near Palmyra that became the founding miracles of a new religion, the Latter-day Saints, Mormonism. A different summer of 1816, and the United States gets a different religion. The second cascade was Europe. By the winter of 1816 and 17, the food crisis had crossed the Atlantic. Eastern Switzerland, densely populated, mountainous, dependent on grain imports, was the worst hit. Populations resorted to eating cats, rats, and grass. For 2 consecutive years, in 1817 and 1818, Switzerland recorded more deaths than births. In Ireland, the wheat, oat, and potato harvest all failed at the north and southwest. The typhus epidemic that followed killed an estimated 65,000 people. This was Ireland's first potato failure famine, over 30 years before the Great Famine of the 1840s. In Bourbon, France, bread prices nearly doubled and food riots spread across the country. In several German and Belgian cities, the riots were large enough to require military suppression. The third cascade was the disease that followed. The failed monsoon of 1816 and the unusual rains of 1817 changed the salinity of the Ganges Delta, the ecological cradle of the bacterium Vibrio cholerae. In a town called Kirko, near modern Calcutta, a new and especially virulent strain of cholera emerged. Within 3 years, that strain was in Bangkok and Manila. Within 6, it had reached the Persian Gulf, Eastern Africa, and the Mediterranean. This was the first global pandemic in human history. Cholera would return 6 more times over the next century. Every subsequent strain descends from the one that emerged in Jessore in 1817. The fourth cascade was animals. Oat, the primary feed for horses, failed across Central Europe in 1816. Oat prices tripled. Horses began to starve. Postal services and military couriers collapsed because they could not afford to feed their teams. In Hakkas, a 32-year-old civil servant named had been sketching in his spare time a horseless personal vehicle. On June 12, 1817, almost exactly 2 years after Tambora's main eruption, he demonstrated it in public for the first time. 2 wooden wheels in a line, a beam to straddle, a saddle to sit on. The rider pushed off the ground with his feet. Dross called it a running machine. We call it the dandy horse or the bicycle. Every 2-wheeled vehicle since, from the penny farthing to the racing bike, descends from that prototype. The bicycle was invented because a volcano on the other side of the world killed the horses. While Drais was sketching mechanical horses in Mannheim, 3 young English romantics were sitting in a villa above Lake Geneva, waiting for the rain to stop. It would not stop. Lord Byron, 28, the most famous poet in Europe fleeing scandal, had rented the villa at the village of Percy Bysshe Shelley. His radical young contemporary had taken a smaller house just down the road. With him was his lover and future wife, Mary Godwin. Mary was 18. The 4th person in the group was Byron's personal physician, Dr. John, 20 years old. The weather that June was, in Mary Shelley's own words, a wet, ungenial summer, continuous cold rain, electrical storms that filled the sky over the lake for nights at a time. On the night of June 16, 1816, the night of the most violent storms, they were reading aloud from a book of German horror tales. Byron put down the book and said, "We will each write a ghost story." Mary went home and over the next several days began drafting a story about a young scientist who builds a man out of dead tissue and brings him to life. She published it 2 years later, anonymously, under a title from Greek mythology. The modern Prometheus, Most people know it by its other title, Frankenstein. She was 18 years old. Polidori took a fragment Byron had abandoned and wrote a short novel called The Vampire, the first modern vampire fiction in English literature. Every aristocratic, seductive, predatory vampire from Dracula to every film and television series after descends from Polidori's 1816 draft. And Byron sat down on the 22nd of July, looked out the window at the dimmed sun, and wrote a poem. I had a dream, which was not all a dream. The bright sun was extinguished, and the stars did wander darkling in the eternal space. A volcanic winter on the other side of the world, recorded in real time in 3 of the most influential pieces of literature in the English language. Modern horror was born in a rainstorm caused by Tambora. There was one more record keeper that summer, a painter. In London, Joseph Millord William, already the most celebrated landscape painter in Britain, watched the sunsets change. The sulfate aerosols from Tambora scattered the shorter wavelengths of light back into space and let the red light through. From the ground, what you saw was a vivid, oversaturated, blood-red sky, sometimes for hours at a time, sometimes for months. Turner painted 65 watercolor sunsets in the 3 years following Tambora. A scientific study in 2014 ran spectroscopic analysis on his pigments and found something striking. The red-to-green ratio of Turner's skies between 1816 and 1818 exactly matches the modeled decay of the stratospheric aerosol veil and gradually returns to baseline by 1820. Turner's canvases are, in a sense, spectroscopic ice cores. He recorded a global atmospheric event with scientifically recoverable fidelity by accident with paint. The shockwave did not stop. In the United States, the 1816 grain shortage made East Coast wheat prices explode upward. East Coast speculators borrowed heavily to buy land in newly admitted western states, Ohio, Indiana, Illinois, to grow grain for famine-priced European markets. When European harvest recovered in 1819, prices collapsed. The Panic of 1819 was the first sustained economic depression in American history. It was the proximate cause of the Jacksonian populist politics that defined the next 2 decades. In southwest China, the rural province of lost rice crops for 3 consecutive years. To ensure against future disaster, Yunnan farmers shifted to a drought-tolerant cash crop they could store and trade, opium. By the 1820s, Yunnan was a major opium-producing region. That production fed directly into the supply lines of the opium wars of the 1840s and 50s. A volcano in the Lesser Sunda Islands helped reshape the political economy of China for the rest of the 19th century. And then there's the science. No one in 1816 knew what had caused any of this. The educated explanations included sunspots, comets, planetary alignment, and divine judgment. The first credible scientific link between Tambora and the year without a summer came in the 1920s, over 100 years after the eruption. The ice core signal of Tambora's sulfate was first identified in the 1980s. The Tambora event is, in effect, the test case for modern climatology. Every volcanic eruption climate model, every attribution study, every paleoclimate reconstruction, they all run their numbers against 1816 first. If the model reproduces Tambora correctly, it is allowed to forecast the future. Here's what the 1816 story is actually about. One mountain on the other side of the world rewrote over 3 years. WADS, the population map of the United States, the global disease ecology, the economic foundation of a major empire, the literature of an entire generation, and the technological adjacency of personal transport. None of the people living through it knew what was happening. They had no concept of stratospheric aerosols, no instruments to measure them, no theoretical framework that connected a volcano in Indonesia to a famine in Switzerland. The cause and the consequence existed in different worlds, separated by 12,000 kilometers of distance and a year and a half of time. But the cause and the consequence were the same event. The world just had not learned yet how to see it as one thing. This is what climate is. It is not background. It is not setting. It is not the slow part of a story, while the politics and the wars and the inventions happen in the foreground. It is a primary historical force. The civilizations that have lasted longest are the ones that learned eventually to read the climate as carefully as they read their enemies. Most civilizations did not learn that in time. 1816 was the loudest warning the modern world has ever received about how fragile climate equilibrium actually is. It was delivered in real time, in writing, in painting, in diary entries, in dead crops, in mass migration. And then, when the sun came back, almost everyone forgot. 2 centuries later, we are running an experiment of comparable forcing, slower this time and human-made. The question the 1816 story asks is not whether the sky can dim again. It is whether, when it does, we will be paying any more attention than the farmers of Vermont and the rice growers of Yunnan paid in the spring of 1816. The mountain is still there. You can hike up Tambora today. The crater is still 6 kilometers wide. The walls are still nearly a kilometer deep. The 2 kingdoms that lived on its lower slopes, Tambora and Pekat, are gone. So are their languages. In 2004, archaeologists found a buried village on the mountainside, perfectly preserved under 3 meters of volcanic ash, utensils on tables, doors still closed, a flash-frozen Pompeii of the Pacific. The eruption is invisible in modern memory. The cascade it set off, 1816, the year without a summer, Frankenstein, the bicycle, the cholera pandemic, the panic of 1819. Those are all famous. The mountain that caused them is forgotten. History remembers what power forgets.